एवरीवन, वेलकम टू यूनिवर्सिटी एकेडमी यूट्यूब चैनल। आज के लेक्चर में हम लोग देखेंगे नेचुरल एंड फोर्स्ड रिस्पांस एंड वी विल आल्सो सी द कॉन्सेप्ट ऑफ इनिशियल कंडीशंस। अगर आपको इन टॉपिक्स के हैंड रिटन नोट्स चाहिए लिंक इज गिवन इन द डिस्क्रिप्शन बॉक्स, यू कैन डाउनलोड फ्रॉम देयर। ओके, सबसे पहले देखते हैं व्हाट इज नेचुरल रिस्पांस एंड फोर्स्ड रिस्पांस। So the response of a network without a source in it is called the natural response. Okay, it means if a network is not connected with a source or an input, then the response obtained is known as a natural response. Response means the output which we are getting without any input is called natural response, and this natural response it give the transient response. Okay, so the transient response it remain only for a short duration of time. Okay, and then after that it will die out. This response, that is the transient response or the natural response, it only depends on the nature of the passive elements. It means the natural response it depends on the type of element, that is it depends on the values of passive elements are that is resistor, inductor and capacitor. So natural response depends on these elements and it is independent of the type of input, because the natural response is obtained when the input is not connected. Okay, so it is independent of the input. Now next let us see what is forced response. The response of a network with a source present in it is called forced response. It means जब हम सिस्टम में सोर्स कनेक्ट कर देंगे, दैट इज इनपुट कनेक्ट करेंगे, देन उससे जो रिस्पॉन्स प्रोड्यूस होगा दैट इज नोन एज फोर्स्ड रिस्पॉन्स एंड इट विल लीड टू स्टडी स्टेट रिस्पॉन्स। ओके, इसकी वजह से जो रिस्पॉन्स आता है उसको हम बोलते हैं स्टडी स्टेट रिस्पॉन्स, एंड दिस रिस्पॉन्स इज इंडिपेंडेंट ऑफ द नेचर ऑफ द पैसिव एलिमेंट। ओके, ये मीन्स RLC की वैल्यूज पे डिपेंड नहीं करेगा एंड इट विल ओनली डिपेंड ऑन द टाइप ऑफ इनपुट विच इज कनेक्टेड टू द सिस्टम. It means total time response is a combination of natural response plus forced response. Okay, so natural response plus forced response. नेचुरल रिस्पॉन्स में क्या है कि हम सिस्टम में कोई भी सोर्स या इनपुट कनेक्ट नहीं करेंगे, स्टिल वी आर गेटिंग आउटपुट. यू विल थिंक हाउ वी आर गेटिंग आउटपुट विदाउट कनेक्टिंग द इनपुट. द रिस्पॉन्स वी आर गेटिंग इज ड्यू टू द इनिशियल कंडीशंस प्रेजेंट इन द सिस्टम. बिकॉज अगर नेटवर्क में पैसिव एलिमेंट्स हैं दैट इज RLC, इंडक्टर एंड कैपेसिटर अगर प्रीवियसली चार्ज हैं, देन उनकी वजह से जो रिस्पॉन्स मीन्स आउटपुट जो प्रोड्यूस होगा दैट इज नोन एज नेचुरल रिस्पॉन्स. एंड in case of forced response we ensure that the capacitor and the inductor which are used in the circuit they should be initially uncharged. Okay, इसीलिए क्या है कि जो नेचुरल रिस्पॉन्स है उसको हम जीरो इनपुट रिस्पॉन्स भी बोलते हैं. ओके, जीरो इनपुट रिस्पॉन्स मीन्स इनपुट इज जीरो. Okay, then we are getting the output because of the initial conditions present in the system. And in case of forced response it is known as zero state response. Means state means initial conditions are zero. Okay, this is known as zero state response. In this case the initial conditions are zero and output, that is response, is obtained because of the input connected to the system. Now because of this it will give the transient response. Okay, transient response stay only for short duration of the time and after that it will give steady state. Okay, this will give the steady state response. Now let us see a question. Question is, consider a continuous time system with the input x of t and the output y of t having the differential equation. Okay, differential equation is d square y of t by dt square minus 3 into dyt by dt plus 2 y of t it is equal to x of t. Also initial conditions are given, that is y of 0 negative value is 2 and y dash of 0 negative value is 0, and system input that is x of t is e to the power 4t into u of t. Now we have to find out ZIR. ZIR is zero input response. It means we have to find out the output when the input is 0. Okay, Next we have to find out ZSR, that is zero state response. It means in this case we have to find out the output due to the system input. That means we have to find out the output due to x of t, and then we have to find out the total output, which is a combination of ZIR and ZSR. So सबसे पहले हम find out कर लेते हैं ZIR. Okay, so that is ZIR is zero input रिस्पॉन्स. सो नाम से ही पता लग रहा है कि इट मीन्स इनपुट ज़ीरो होगा, उस टाइम पे जो रिस्पॉन्स मिलेगा दैट इज़ आउटपुट जो हमें मिलेगा दैट इज़ नोन एज ZIR. ओके, सो यहाँ पे क्या है कि हम इनपुट को ज़ीरो assume कर लेंगे, that is input here is x of t, so input is 0. Then the response we are getting due to initial conditions, so it means we have to consider the initial conditions, that is y of 0 negative we will consider as 2 and y dash of 0 negative given the question is 0. Okay, so using this three values we have to find out the output. Okay, so now the differential equation, it will become d square y of t by dt square minus 3 into d of yt by dt plus 2 into y of t. So now x of t value is 0, so substitute x of t is equal to 0 because we are finding the ZIR, that is zero input response. Okay, now let us apply the Laplace transform on both the side. So taking the Laplace transform, okay, and we will use the property, that is differentiation in time. So using differentiation in time property, differentiation in time property, so let us apply. So यहाँ पे क्या है कि डी स्क्वायर वाई ऑफ टी बाई डी टी स्क्वायर, सो दिस इज सेकेंड ऑर्डर डेरिवेटिव, सो इट्स लैपलेस ट्रांसफॉर्म, इट विल बी गिवन बाय एस स्क्वायर बिकॉज सेकेंड डेरिवेटिव है, देन वाई ऑफ एस, then the power of s will decrease, so s power 1, and initial conditions it is y of 0 negative, then s power 0 is 1, y dash of 0 negative. Okay, so this is the Laplace transform of d square y of t by dt square, then we have minus of 3 and the Laplace transform of dy t by dt. तो ये क्या है, फर्स्ट ऑर्डर डेरिवेटिव है. ओके, सो एस पावर इज 1 इंटू वाई ऑफ एस, देन एस की पावर डिक्रीज होगी, दैट इज एस पावर 0, इट इज़ 1 इंटू वाई ऑफ 0 नेगेटिव. ओके, देन 2 and Laplace of y of t is y of s, it is equal to 0. Now let us substitute the value. So y of 0 is given 2 and y dash of 0 negative is 0 value. Okay, so y of 0 negative value is 2 and this value is 0. Okay, and similarly here y of 0 negative value is 2. So let us substitute, it will be equal to s square y of s. Okay, and it will be minus 2 into s, so this is 0, it will be minus 3s into y of s. Okay, and this is minus minus, it will become plus 6 plus 2 into y of s, it is equal to 0. So now if we take y of s common, we are getting s square. Okay, then it will be minus of 3 into s, then plus 2, and this 2s and this 6 will go on the right hand side, so it will become plus 2s and this is minus 6. So now if we find y of s, then it will be given by 2s minus 6 divided by, it will be equal to s square minus 3s plus 2. So let us find the factor of this denominator polynomial. So it will become 2s minus 6 divided by, its factor will be s minus 1, okay, and s minus 2. Okay, so we can solve this using the partial fraction. Now let us solve using the partial fraction. So y of s is 2s minus 6 by s minus 1 into s minus 2. So y of s is 2s minus 6 by s minus 1 into s minus 2. So now let us make its factor, that is a by s minus 1, then plus b by s minus 2. So now we have to find out the value of these residues a and b. Okay, so a के डिनोमिनेटर में है s माइनस वन, सो वी विल इक्वेट द डिनोमिनेटर पॉलिनोमियल एज जीरो. सो s माइनस वन इज इक्वल टू जीरो, so we are getting s is equal to 1. It means we have to substitute s is equal to 1 in the left hand side expression except here. मतलब यहाँ पे आपको पुट नहीं करना, बिकॉज अगर आप यहाँ पे s is equal to 1 पुट करेंगे देन इट विल बिकम इन्फिनिटी. ओके, सो इस वाले टर्म को छोड़ के आपको रिमेनिंग टर्म में s is equal to 1 सब्सटीट्यूट करना है. सो इट विल बिकम 2 into 1 that is 2 minus of 6 divided by, it will become 1 minus of 2. So it will be equal to minus of 4 by minus 1. It means you are getting 4. So this is the value of a. Okay, so a value we are getting as 4. Similarly, we have to find out the value of b. So for that we have to equate the denominator polynomial as 0. So we will equate s minus 2 is equal to 0. So we are getting s is equal to 2. So this will be, so substitute s is equal to in this expression except this, because अगर यहाँ पे 2 पुट कर देंगे तो अगेन वो इन्फिनिटी बन जाएगा. ओके, so substitute s is equal to 2, it will be equal to 2 into 2 is 4 minus of 6 by 2 minus 1. So this is minus of 2 by 1. So we are getting minus of 2 and this is the value of b. Okay, so b value we are getting minus of 2. So let us substitute. Okay, so then y of s, it will become, a value is 4 by s minus 1, then b value is minus of 2 by s minus of 2. Now if we take inverse Laplace transform, then we are getting y of t. So यहाँ पे क्या है कि जो आउटपुट हमें मिल रहा है दैट इज y ऑफ t, उसको हम बोलेंगे आउटपुट ड्यू टू जीरो इनपुट रिस्पॉन्स, बिकॉज यहाँ पे हमने x ऑफ t को जीरो एज्यूम किया. सो यहाँ पे हमने क्या है, जीरो इनपुट रिस्पॉन्स फाइंड आउट करने के लिए एक्स ऑफ टी को जीरो इक्वेट किया था. ओके, सो दैट इज वाई द आउटपुट वी आर गेटिंग इज नोन एज अ जीरो इनपुट रिस्पॉन्स. सो इट इज इक्वल टू 4. ओके, सो इनवर्स लैप्लेस ऑफ 1 बाय एस माइनस 1. ओके, सो लैप्लेस इनवर्स ऑफ 1 बाय s plus a. Okay, so inverse Laplace transform of 1 by s plus a is given by e to the power minus of at into u of t. Okay, so if we compare it with this expression, so here a value is minus 1, so it will be equal to e to the power t into u of t. Okay, and then minus of 2. Okay, and here a value is minus of 2, then it will become e to the power 2t into u of t. Okay, so this is zero input response. Now in the b part we have to find out zero state response. So this is second part, and in this part we have to find out zero state response. Okay, so this is zero state response. Okay, so in the zero state response the output is due to the input. Okay, so now here input is x of t, given in the question is e to the power 4t into ut. So okay, this is system input which is given by e to the power 4t into u of t. Okay, and in the zero state response the initial conditions it will be zero. It means यहाँ पे क्या है कि हम y of 0 negative and y dash of 0 negative की जो value है it will be 0. Okay, so let us write. So y of 0 negative which is initial conditions, उसकी value 0 होगी. Similarly y dash of 0 negative value will also be 0. So इन equations को solve करेंगे, that is we will be using to get the output, and that output will be known as zero state response. Okay, so now the differential equation will be d square y of t by dt square minus of 3 dyt by dt plus 2 into y of t. Now we have to use x of t value, so let us write the differential equation which is d square y of t by dt square, it was minus of 3 into dyt by dt. Okay, and then it is plus 2 into y of t is equal to x of t. Okay, now let us apply the Laplace transform. Okay, so taking the Laplace transform on both the sides, so we will be getting, so यहाँ पे क्या है, सेकेंड ऑर्डर डेरिवेटिव है, सो इट विल बिकम एस स्क्वायर वाई ऑफ एस माइनस एस इंटू वाई ऑफ ज़ीरो नेगेटिव माइनस ऑफ वाई डैश ऑफ ज़ीरो नेगेटिव. ओके, देन इट इज़ माइनस ऑफ 3 इंटू एस इंटू वाई ऑफ एस माइनस वाई ऑफ ज़ीरो नेगेटिव then plus 2 into y of s is equal to x of s. Okay, so here y of 0 negative, that is initial conditions are 0, so y of 0 negative is 0, y dash of 0 negative is also 0, and this is also 0, so all the initial conditions are 0. So let us substitute, then it will be s square y of s, so ये term दोनों term तो 0 हो गए, then it will be minus of 3s into y of s. Okay, then it will become 0, then plus 2 into y of s is equal to, so now we have to find out the value of x of s. Okay, so now here x of t value, that is input, is e to the power 4t into u of t. Now we have to find out x of s, so I have told that is the Laplace transform of e to the power at into ut is given by 1 by s minus of 4. Okay, so in the very first lecture, I have explained you the Laplace transform of e to the power at into ut is given by 1 by s minus of a. Okay, so here a value is 4. So iska jo Laplace transform hai, that is x of s value, we are getting 1 by s minus of 4. Okay, so now let us take y of s common. We are getting, so if we take y of s common, we are getting s square. Okay, s square minus 3s plus 2, so this is s square minus of 3s plus 2, this is equal to 1 by s minus of 4. Now y of s we are getting 1 by, so the factor of s square minus 3s plus 2 will be equal to, so s minus 1. Okay, so s minus 1 and s minus 2 are the factor of this quadratic equation, that is s square minus 3s plus 2. Then we have in the denominator already s minus 4 is there. Okay, so now we will solve this using the partial fraction, so its factor will be a by s minus 1, then b by s minus of 2, then c by s minus of 4. So we have to find out the value of this a b c. Okay, so ए के डिनोमिनेटर में है s माइनस 1, सो इक्वेट s माइनस 1 इज इक्वल टू 0, सो वी आर गेटिंग s इज इक्वल टू 1. सो सब्सटीट्यूट s इज इक्वल टू 1 इन दिस एक्सप्रेशन एक्सेप्ट दिस टर्म. ओके, सो इट विल बी 1 बाय, न्यूमरेटर में तो 1 रहेगा, एंड डिनोमिनेटर इट विल बी इक्वल टू 1 माइनस ऑफ 2 इंटू 1 माइनस ऑफ 4. So this will be equal to 1 by, this is minus 1 and this is minus of 3, so we are getting 1 by 3. So this is a value. Okay, so a value we are getting 1 by 3. Similarly we will find the value of b. So for b we will equate s minus 2 is equal to 0, so we are getting s is equal to 2. Okay, so we will substitute here except this term. Okay, so यहाँ पे नहीं put करेंगे because it will become infinity, so it will be equal to 1 by s value is 2, so this is 2 minus of 1 into 2 minus of 4, so we are getting 1 by 2 minus 1 is 1 into this is minus of 2, so we are getting b value as minus of 1 by 2. Okay, so b value is minus 1 by 2. Okay, similarly we will put s minus 4 is equal to 0, so we are getting s is equal to 4, so it will become 1 by 4 minus 1, this is 3, and then 4 minus 2 is 2, so this is 1 by 6, so this is c value. Okay, so c value we are getting 1 by 6. So now we have obtained the value of a, b and c, so we will put in this equation, suppose it is equation 2, so we will substitute here and then we will apply the inverse Laplace transform. So a value we have obtained is 1 by 3 by s minus 1. Okay, so this is 1 by 3 into s minus 1. Then b value we have obtained minus 1 by 2 into s minus 1. Okay, so this is minus of 1 by 2 into s minus of 2, and c value we have obtained is 1 by 6. Okay, so this is 1 by 6 into s minus of 4. Okay, now let us apply the inverse Laplace transform. Okay, so we will be getting y of t, and now this output is known as the zero state response because this is the output due to the input present in the system and initial conditions are 0. Okay, So 1 by 3 into s minus 1 का inverse Laplace transform is 1 by 3. It will be equal to e to the power t into u of t. Okay, then it is minus of 1 by 2 into e to the power 2t into u of t, and then it is 1 by 6. 1 by s minus 4 का inverse Laplace transform is e to the power 4t into u of t. Okay, so and in the last part, that is in the third part, we have to find out the total output. Okay, so the total output y of t, it will be a combination of due to output due to zero input and the output due to the zero state response. Okay, so we have calculated both the responses. Okay, so zir we have obtained is, okay, so zir is this. Okay, so this is y of t zir. Okay, and we have also obtained this is y of t due to ZSR. Okay, now substitute both these y of t value, okay, and you will get the final output. So it will be 4 into e to the power t into u of t, and minus of 2 into e to the power 2t into u of t. Okay, so this is zir, and ZSR is 1 by 3 into e to the power t into u of t minus of 1 by 2 into e to the power 2t into u of t plus 1 by 6 into e to the power 4t into u of t. Okay, so this part is known as, that is zir की वजह से जो है, that response is known as transient response. Okay, and ZSR की वजह से जो output आ रहा है, that is response, this response is known as steady state response. Okay, सो नाउ लेट अस सी द नेक्स्ट क्वेश्चन. एंड आपको अगर आपको वीडियो अच्छी लग रही है तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें, एंड चैनल को अभी तक आपने सब्सक्राइब नहीं किया तो सब्सक्राइब भी जल्दी से कर लें. ओके, सो क्वेश्चन इज, consider a continuous time system with the input x of t and the output y of t having the differential equation. So differential equation is d square y of t by dt square plus 2 into dy t by dt प्लस y ऑफ टी इज इक्वल टू x ऑफ टी. सो यहाँ पे क्या है कि इनिशियल कंडीशंस गिवन है, दैट इज y ऑफ जीरो नेगेटिव वैल्यू इज माइनस ऑफ 2 एंड y डैश ऑफ जीरो नेगेटिव वैल्यू इज 0. तो यहाँ पे क्या है कि जो सिस्टम इनपुट है, दैट इज x ऑफ टी, इट्स वैल्यू इज डेल्टा टी. सो डेल्टा टी इज यूनिट इम्पल्स input. Okay, so this is unit impulse input. We have to find out d of yt by dt at t is equal to 0 positive. Okay, so at this instant we have to find out the value of d of yt by dt. So फर्स्ट ऑफ ऑल जो हमें डिफरेंशियल इक्वेशन गिवन है उसमें हम लैपलेस ट्रांसफॉर्म अप्लाई करेंगे, एंड देन सबसे पहले हम y ऑफ टी फाइंड आउट करेंगे. देन जो y ऑफ टी का जो एक्सप्रेशन हमें मिला उसे हम डिफरेंशिएट करेंगे विद रिस्पेक्ट टू t, एंड देन उसमें हम t इज इक्वल टू 0 पॉजिटिव सब्सटीट्यूट करेंगे. ओके, सो डिफरेंशियल इक्वेशन इज डी स्क्वायर y ऑफ टी बाय डी टी स्क्वायर प्लस 2 into d of yt by dt. Okay, and then plus y of t. So here x of t is delta t. So now let us apply the Laplace transform. Okay, so on both the sides, so taking the Laplace transform on both the sides. Okay, so it will be, so यहाँ पे कहते हैं सेकेंड ऑर्डर डेरिवेटिव है, so it will be equal to s square y of s minus s into y of 0 negative minus में y dash of 0 negative, then it is plus 2 s into y of s because it is first order derivative minus y of 0 negative. Okay, then y of t का जो लैप्लेस है, it is y of s, and x of t का जो लैप्लेस है, it is x of s. Okay, so y of 0 negative value is, this is minus of 2, and y dash of 0 negative value is 0, and this is y of 0 negative, so its value is 2. सो एक्स ऑफ एस हेयर इज, सो यहाँ पे क्या है कि जो इनपुट हमें गिवन है, दैट इज एक्स ऑफ टी, इट इज डेल्टा टी. ओके, सो द लैप्लेस ट्रांसफॉर्म ऑफ यूनिट इम्पल्स इनपुट इज 1. इट मीन्स एक्स ऑफ एस हेयर is 1. Okay, so let us substitute. It will be equal to s square y of s, and minus minus it will be equal to plus 2 into s, this is 0, and then it is 2s into y of s. Okay, this minus minus it will be plus, and 2 into 2 is 4 plus y of s, and x of s value is 1. Okay, so now let us take y of s common. It will be equal to s square plus 2s plus 1. Okay, so if we take y of s common, we are getting s square plus 2 of s plus 1. Okay, and 2s, and this 4 will go on the right hand side, so it will be 1 minus of 4 minus 2s. Okay, so this is equal to 1 minus of 4 minus of 2s. Okay, so from here we are getting y of s, it will be equal to minus of 2s, and 1 minus 4 is minus of 3 divided by, so this is s square plus 2 of s plus 1. So this can be written as minus 2s minus 3. So s square plus 2s plus 1 is nothing but s plus 1 whole square. So a plus b whole square is a square plus b square plus 2ab, so it will give s square plus 2s plus 1. Okay, so now we can rearrange this as, so minus of 2, so in place of s we can write s plus 1. Okay, so it will become minus 2s minus 2, but we want minus 3, so we have to add minus 1 here in the numerator, and it will be equal to s plus 1 whole square. Okay, so this y of s, it will become minus 2 by s plus 1, and this s plus 1 whole square will get cancelled out, so we will be left with minus 2 by s plus 1, and it is minus 1 by s plus 1 whole square. Okay, so now let us apply the inverse Laplace transform. Then we are getting y of t expression, so it will be equal to minus of 2. Okay, and inverse Laplace of 1 by s plus 1 is e to the power minus of t into u of t. Okay, then minus sign is there. Then inverse Laplace of 1 by s plus 1 whole square, so because of square t will come, and inverse Laplace of 1 by s plus 1 is e to the power minus of t into u of t. Okay, so यहाँ पे क्या है कि हमें y of t का expression मिल गया, and we have to find out d of yt by dt at t is equal to 0 positive. So now let us differentiate this equation. So we are getting d of yt by dt. Okay, so this will become, so first of all let us take u of t common, so that our derivative become equal, oh sorry, easy. So then y of t, it will be equal to, so if we take u of t common, then it will be equal to minus of 2 into e to the power minus of t, then it will be minus of t into e to the power minus of t. Okay, and I have taken u of t common. Now let us differentiate this equation. So now let us differentiate it. So d of yt by dt, it will be, so we can differentiate, so differentiation by part. So let us assume this is part 1, and u of t, this is part 2. Okay, so differentiation by part is first function as it is. Okay, so minus of 2 into e to the power minus of t minus t into e to the power minus t. Okay, so first function as it is, differentiation of second, so second function is u of t, so d by dt of u of t. So if we differentiate u of t, that is unit step function derivative is delta of t. Okay, so it will be delta t plus second function as it is, so second function here is u of t into differentiation of first. Okay, so first function is a combination of two terms, so the differentiation of minus 2 into e to the power minus t is given by minus of 2 into e to the power minus of t, and the differentiation of minus of t is minus of 1. Okay, then plus the differentiation of this term, it will be equal to, okay, so let us take minus sign common. Okay, so it will be equal to minus, and the differentiation of t into e to the power minus t, it will be equal to, so first function as it is, that is I am taking this as first function and this is second function. So first function as it is, differentiation of e to the power minus t is e to the power minus t into minus of 1 plus second function as it is, and differentiation of t is 1. Okay, so let us expand. So we are getting, So this will be equal to minus of 2 into e to the power minus of t minus t into e to the power minus of t into this is delta of t, okay, and it will be equal to, so this minus 2 and then minus 1, it will be equal to plus 2 into e to the power minus of t, okay, and this minus 1 multiplied with minus, it will be equal to plus t into e to the power minus of t, okay, and this minus sign, it will become minus into e to the power minus of t, and u of t will come here, okay. Now we have to find out d of yt by dt at t is equal to 0 positive, okay. So t is equal to 0 positive means at the time just after 0, okay, that is, let us substitute t is equal to 0 positive. So now at t is equal to 0 positive, so as we know that impulse function is defined only at t is equal to 0, so this is delta of t with respect to t, so its waveform is like this. It is only defined at t is equal to 0, so impulse function value at t is equal to 0 positive, it means somewhere here its value will become 0. So it means delta of t at t is equal to 0 positive, this value is 0, and u of t function value at t is equal to 0 positive, its value is 1, because unit step function is given by this, okay. So this is u of t, its amplitude is 1 for the t greater than 0, okay. So at t is equal to 0 positive, it means somewhere here its value is 1, okay. So it's u of t at t is equal to 0 positive is plus 1, so this entire term it will become 0, okay, and it will be equal to 2 into e to the power minus of t, okay, and then this is plus t into e to the power minus of t minus e to the power minus t into this is 1, okay. So if we substitute, this is 2 into e to the power minus t, minus of this, it will become e to the power minus of t, and if we substitute t is equal to 0 positive, it will become 0. So at t is equal to 0 positive, it will be equal to e to the power 0, which is equal to 1. So the value of dy by dt at t is equal to 0 positive, we are getting 1, okay. Now the next topic is concept of initial conditions. So due to the presence of energy storage element such as inductor and capacitor in the circuit, we come across the concept of initial conditions, okay. So basically initial conditions is, it describe the energy stored in the every capacitor and every inductor, okay. So let us first consider the inductor, okay. So let me draw inductor, okay. So this is inductor, and suppose the voltage across the inductor is v of t, and the current flowing through inductor is suppose I of t. So now we know the relation between v and I, that is voltage across the inductor, it is given by L into d of it by dt, okay. So this is voltage across inductor, and if we find out the current expression in terms of voltage, then the current across the inductor, it will be given by 1 by L integration from minus infinity to t v of t dt, okay. So now inductor is designed to store the energy in the form of magnetic field. So if we have to find out the power dissipation across the ideal inductor, then it will be given by vi cos phi, okay. So where phi is the angle between voltage and current, and we know that in case of pure inductor, the current, it will lag the voltage by 90 degree, okay. So this is for the pure inductor, the vi waveform is like this, okay. So in case of pure inductor or ideal inductor, करंट जो है वो वोल्टेज से लैग करेगा बाय द 90 डिग्री, इट मीन्स वोल्टेज और करंट के बीच में जो एंगल है दैट इज 90 डिग्री. सो लेट अस सब्स्टिट्यूट हियर, सो दिस इज cos of 90 degree and cos 90 is 0. So it means the power dissipation in case of ideal inductor, it is 0 watt, okay. So in case of ideal inductor, the power dissipation is 0. So that is why we say that inductor is designed to store the energy in the form of magnetic field. So let us find out the amount of energy stored in the inductor. So suppose it is denoted by E. So energy, it is given by integration of power with respect to time from the interval 0 to t, okay. So power is given by product of voltage and current, that is v of t into I of t into dt from 0 to t. And we know that the voltage across the inductor, it is given by L into d of it by dt into, this is I of t into dt. So this dt will get cancelled out. So energy we are getting from 0 to t, this is L into I of t into d of it. So if we differentiate this equation, we are getting energy after integration, we are getting energy stored in the inductor, it is given by half of L into I square. Okay, so L is the inductance value and I is the current flowing through the inductor. So this is the amount of the energy stored in the inductor, and this is in the form of magnetic field. Okay, so this much amount of energy is stored in the inductor, that is given by half of L into I square. Okay, so the power dissipation in an ideal inductor is 0. So we have seen this point, that is power dissipation is 0 watt because inductor is designed to store the energy. Okay, and the inductor, it store the energy in the form of magnetic field, and the amount of energy stored is given by half of L into I square. Okay, next point is, for the DC source, under the steady state condition, the inductor will act as short circuit. So this is important point. Okay, so that is, if we are connecting a DC source and the circuit is under the steady state condition, it means the transients have died out. Okay, then the inductor will act as short circuit. Okay, so as DC source is connected and the circuit has reached under the steady state condition, so then the current will become constant. Okay, because the circuit is under the steady state, तो जो transient है वो cancel out हो जाएंगे. Okay, तब तक, and DC source की वजह से क्या है कि जो current है it will be constant, and we know that the voltage across the inductor is given by L into d of I by dt. Okay, so as current is constant, this implies that the derivative of current with respect to time, it will be 0 because current is constant and the differentiation of constant is 0. So if we substitute di by dt here 0, then we are getting the voltage across the inductor as 0 volt. Okay, so this implies that the voltage across the inductor is 0. It means the inductor will become short circuit under the steady state condition. Okay, under steady state condition. Next point is, an inductor does not allow the sudden change in current because for the sudden change in current an infinite voltage is required, which is practically not possible. So this is also important point. So we know that voltage across the inductor is given by L into di by dt. It means अगर हमें suddenly current को change करना है through the inductor, then the change in the current, it should be finite and the change should be sudden. It means dt, it will tend to 0. Okay, so it means the voltage across inductor, it is given by L into di. So di is a change in current, it should be finite, so that is given by finite, and the current should change suddenly. It means the time is tending to 0. So it means the voltage across the inductor, we are getting infinity. It means practically it is not possible to provide the infinite voltage across the inductor. So that is why we say that inductor does not allow the sudden change in current. इट मीन्स इंडक्टर के थ्रू जो करंट फ्लो कर रहा होगा एट टी इज इक्वल टू 0 नेगेटिव, सेम करंट विल फ्लो थ्रू द इंडक्टर एट टी इज इक्वल टू 0 इंस्टेंट, एंड सेम करंट विल फ्लो थ्रू द इंडक्टर एट टी इज इक्वल टू 0 पॉजिटिव, बिकॉज इंडक्टर डज नॉट अलाउ द सडन चेंज इन करंट, बट वोल्टेज की जो पोलैरिटी है अक्रॉस द इंडक्टर इट कैन चेंज. ओके, सो सिमिलरली लेट अस सी द कैपेसिटर. So first point is, the power dissipation in an ideal capacitor is 0. So ideal capacitor means no resistance is there in series with the capacitor. Okay, so अगर ideal capacitor है, then the current will lead the voltage by 90 degree. Okay, so the power expression, it will be given by VI cos phi. Again phi value is 90 degree because current जो है वो voltage से lead करता है by the 90 degree, and cos 90 is 0. So power dissipation in case of ideal capacitor, it will be 0 watt. Next point is the capacitor store the energy in the form of electric field, and the energy stored in the capacitor, it is given by the formula half of C into V square. Okay, and similarly for the DC source under the steady state condition, the capacitor will act as open circuit. So इंडक्टर जो था वो शॉर्ट सर्किट हो गया था, बट कैपेसिटर अंडर द स्टडी स्टेट कंडीशन फॉर द डीसी सोर्स इट विल बिकम ओपन सर्किट, बिकॉज अगर हम डीसी सोर्स कनेक्ट कर रहे हैं एंड द सर्किट इज अंडर द स्टडी स्टेट, देन द वोल्टेज इट विल बिकम कांस्टेंट. Okay, and we know that the current through the capacitor, it is given by C dv by dt. So the dv by dt, it will become zero because differentiation of a constant is zero. So this implies that the current through the capacitor is zero. So if the current is zero, it means it is becoming open circuit. So it means the capacitor, it is replaced by open circuit under the steady state condition. Okay, so inductor जो था वो शॉर्ट सर्किट होगा एंड कैपेसिटर इट विल बिकम ओपन सर्किट अंडर द स्टडी स्टेट फॉर द डीसी सोर्स. एंड लास्ट पॉइंट इज a capacitor does not allow the sudden change in voltage, because for the sudden change in voltage an infinite current is required, which is practically not possible. So we know that the current through the capacitor, it is given by C into dV by dt. तो अगर हमें capacitor के across suddenly voltage को change करना है, then the change in the voltage it should be finite and it is changing suddenly, it means within no time. So it means dt is tending to 0, then the current across the capacitor, it is given by C into dV, it will be finite and time is 0. So it means the current through the capacitor, it is becoming infinity, so which is not practically possible. Okay, so that is why we say that capacitor, it does not allow the sudden change in voltage. So it means the voltage across the capacitor at t is equal to 0 negative, it will be equal to the voltage across the capacitor at t is equal to 0, and it will maintain the same voltage at t is equal to 0 positive. Okay, so this is the important point. Okay, so t is equal to 0 negative पे जो capacitor के across voltage होगी, same voltage t is equal to 0 positive पे भी रहेगी at, I mean across the capacitor at t is equal to 0 positive, because capacitor will not allow the sudden change in voltage. Okay, so आज के लिए इतना ही. नेक्स्ट लेक्चर में हम लोग स्टार्ट करेंगे ट्रांजिएंट रिस्पॉन्स. सो थैंक यू.